Welcome back. This is the beginning of Unit 8, Week 7, Lecture 15. In this lecture, we're going to talk about functional groups. We're still talking about organic chemistry, but so far we've really just been looking at hydrocarbons and different varieties of hydrocarbons and how to represent those hydrocarbons using the molecular formula, structural formula, and line angle drawings. Now we're going to add some interesting variety to our basic understanding of organic chemistry by looking at functional groups. Functional groups are distinctive arrangements of groups of atoms that impart characteristic physical and chemical properties to the molecules that contain them. That's the definition of a functional groups. What does all that mean? Well, distinctive arrangements of groups of atoms, for example, oxygen, how oxygen might be bound to the hydrocarbon with a double bond or just as a single bond with a hydrogen or with a double bond and another oxygen. These different arrangements of groups of atoms, oxygen containing or nitrogen containing, give particular characteristic physical properties that change the simple alkane into a more interesting molecule and allow the organic chemist to more easily build molecules by combining functional groups. There's specific chemical reactions, and also there's this unique characteristic of organic molecules. It's called, or molecules in general, but it's called the structure-function relationship. And when we add functional groups and change structures, we then change the behavior of the molecules. For example, ethane and ethanol. Ethane is just, your basic alkane, saturated hydrocarbon, and ethanol is the same molecule except one of the hydrogens has been substituted out. It doesn't matter which one in this case, but one of the hydrogens, let's say this one, has been substituted out for what's called a hydroxyl functional group. Hydroxyl. Sometimes it's called a hydroxyl functional group. Sometimes it's called an alcohol functional group. It's the same thing. But anyway, this changes the characteristics, the physical and chemical characteristics of this basic alkane when you add this OH group. For example, ethane at room temperature and pressure is a gas, whereas ethanol at room temperature and pressure is a liquid. Okay, big difference between the two of these, big differences in what types of molecules they will react with because of this now present functional group. So this would be considered a functional group on this hydrocarbon. There's a slew of functional groups, and I showed them to you here, broken into two parts. This table is broken into two parts because they are so important, and we're going to be looking at polymer chemistry, and we're going to be looking at a little bit of synthetic chemistry to start understanding some drugs and why drugs work. Certain drugs work in certain capacities and others in other capacities. And then we're going to be looking at biochemistry. All of the basic functions of these different molecules comes down to what functional groups are or are not on the molecules. So we just need to be familiar with these different types of functional groups, and this is a matter of just taking about 30 minutes to take your time to read through these and become familiar with them. And then I've supplied with a lot of homework to where you can practice identifying them. So first of all, the hydroxyl, that's what we've already looked at. The generic formula is an OH group, and it's just got this line here indicating that it's bound to some hydrocarbon. Sometimes they put an R here to indicate like the rest of the molecule. Okay. Anyway, there's in this column all the way through this table, they're giving the name of a common type of a molecule that contains that particular functional group. And in this case, it's ethanol, which we just looked at on the previous slide. And you can see the functional group is in red, and then you see the condensed structural formula here. All right, and the next one listed here is ether. An ether functional group is when a carbon has a single bond to an oxygen, and then the oxygen is a single bond to a carbon. So the rest of the hydrocarbon exists on either side. The simplest ether is dimethyl ether because there's a methyl group on either side of the oxygen. Okay, and here's two different ways to represent it. Alrighty, so I'm not going to expect you to name a bunch of big complicated organic molecules, but these very simple names you should be familiar with. Alright, okay, the third type is the aldehyde, and this is the basic generic formula. The carbon would be bound to the rest of the molecule, you know, and then there's a carbon, a double bond to oxygen, and then a hydrogen. So the aldehyde functional group always comes at the end of a hydrocarbon chain. And here you see it at the end, propanol, because there's three carbons, 1, 2, 3, and it's not propanol, it's propanal. So the aldehyde has the Al suffix. That's how you know it's an aldehyde. And this is how we represent it. A ketone. A ketone is when you have in the middle of a hydrocarbon, not on the end of the chain, but on it's got to be in the middle, a carbon double bond to oxygen. The simplest one is 2-propanone, or sometimes it's called dimethyl ketone. And the common name for this is acetone. It's a common ingredient in fingernail polish remover, and you can get it at the in large quantities of it at a hardware store for using with painting and whatnot. So anyway, this is the simplest one. The common name is acetone. The phenyl group is considered a functional group. It's C6H5, and it would be stuck to the rest of the molecule. This is the symbol that's used, but you need to know that it's the same thing as a benzene ring, only it's, you know, stuck to the rest of the organic molecule. And the benzene ring is a cyclic hydrocarbon with 3 double bonds, and because the double bonds can exist in these two conformations, this is actually a resonance structure, and it's drawn like this with the circle in the middle to indicate resonance, because really each one of these bonds between these carbons is like a 1.5 bond rather than double single double single. It's in between. Remember, it's sort of like ozone. Remember with ozone was like a 1.5 bond instead of a full double full single. This is the same deal here. And so the formula is for a benzene ring is C6H6, but for this phenyl it's C6H5 because one of the hydrogens is substituted out for, we know, whatever the rest of the molecule is here, whatever it's stuck to. Okay, when it's like that, it's considered a functional group, adds functionality to this to the molecule, whatever it's stuck to. Okay, the rest of the table here, carboxylic acid. That also is always going to come at the end of a branch or a chain, a hydrocarbon chain. And here's the simplest one, ethanoic acid. Actually, the simplest one, yeah, no, would be formic acid, because it would just be one carbon with a hydrogen here. That would be formic acid, which is the acid that's in fire ants. But anyway, this one's got a 2-carbon chain, and this is ethanoic acid. It's a very common acid. It's acetic acid. Acetic acid is the acid that's in vinegar, okay? And this is how we draw it. So you just need to study that it's always at the end, and C double bond O, OH. This cluster is the carboxylic acid functional group. When the C double bond O is not at the end, and there's a continuing with a carbon on the other side of it, then that is called an ester. And here's a simple ester methyl ethanoate or methyl acetate. Anyway, esters are found a lot in nature, as are all of these, but in particular, they normally have a nice smell. So the nice odors that come from flowers and whatnot are typically esters. Anyway, the amine functional group is whenever you have an N bound to a carbon, and sometimes the N has not just 2 H's, but it could have another carbon here as well. And so this is called the amine functional group, and this is the simple ethylamine. You could have methylamine, ethylamine. Of course, NH3 is just ammonia, right? So you've at least got to substitute out one of the hydrogens for some alkyl group. And then the last one here is the amide functional group. This one we're going to see again and again when we look at proteins. But anyway, the amide functional group is always a carbon double bond oxygen bound to a nitrogen. And it could be a terminal like this where there's 2 hydrogens, or it could be in the middle where you have of a molecule like this hydrogen could be R, like the rest of the molecule going on. Alrighty, so this is an amide functional group. Okay. All right, so you need to be familiar with those. You just need to take some time. I've given you a lot of homework problems to practice identifying functional groups.